We can use multivariate analysis to actually detect the presence of confounding in our data. So this table is an actual table from a research article that I published. In this particular article, we were looking at the association between race, ethnicity, and whether someone was denied health or life insurance after the Affordable Care Act. So our independent variable was race, ethnicity, and our outcome variable was the denial of health or life insurance. In this particular table, we displayed the results of our logistic regression analyses. So we used a logistic regression because our outcome variable was binary, whether someone was denied health or life insurance. That was categorized as yes or no. And in this table, what you're looking at is you can see the categories for our independent variable, which is race, ethnicity. This group, those who identify as white, that value is going to be our unexposed or our reference category, which is why you see this odds ratio of 1 here and odds ratio of 1 here. And then what we're doing is we are essentially comparing the other categories of race, ethnicity as the exposed groups to this unexposed group of white non-Hispanics. So in this first column here, we're showing the unadjusted odds ratios for our unadjusted logistic regression analysis that we ran. And then in this column here, we are controlling for several variables. So we're throwing those potential confounders into our logistic regression model in our statistical software. And now we're calculating adjusted measures of association that account for those potential confounders. In this case, information on what we adjusted for is included in the footnotes here. And what you can see is that we adjusted for the variables in this table. So the variables we adjusted for included sex, income, employment, as well as survey year. And we were able to, using that adjusted logistic regression, we were able to calculate odds ratios that are adjusted for those potential confounders. So in this column here, we have unadjusted or our crude odds ratios for the relationship between race, ethnicity, and the denial of health or life insurance. And then in this column here, we have the adjusted odds ratios. So the odds ratios that are adjusted for those potential confounders for the relationship between race, ethnicity, and the denial of health or life insurance. So to detect confounding, remember, we are comparing our crude or unadjusted measure of association to our adjusted measure of association. So just like we did with the stratified analysis, we are going to compare our crude or unadjusted to our adjusted. And using the formula we talked about, we would take those numbers and we would see, is there a 10% difference between those numbers or greater? So for example, I would compare the odds ratio here for my Black non-Hispanic group. I would compare that 3.08 to the 3.0, which is my adjusted, and I would say, all right, I'm going to take 3.08 minus 3.0 divided by 3.0 times 100, which gives us a percent change that is definitely less than 10%. So just looking at that row, I would say, all right, we don't have confounding present. But if I look at the next row for the other non-Hispanic group, I would take that 2.56, subtract 2.16, and divide by the 2.16 times 100. And in this row, I see, oh, my percent change is greater than 10%. It's actually a little over 18%. So now it looks like I actually do have confounding present in my study. And if I look at that last row for those who identify as Hispanic, I see that my unadjusted is 2.77, while my adjusted is 2.13. I would take that 2.77 minus 2.13 divided by 2.13. And I would conclude that, yeah, that percent change is a lot higher than 10%. It's actually somewhere around 30%. So based on those percent change calculations, I would conclude, yes, indeed, I do have confounding. Sex, income, employment, and survey year, they do confound the relationship between race, ethnicity, and health or life insurance denial. So what I would need to do then, since I I have shown that I have confounding in my study, I would need to report, in terms of the overall findings of this study, I would report these adjusted odds ratios, because these adjusted odds ratios are a more valid estimate of the relationship between race, ethnicity, and the denial of health or life insurance. The unadjusted or the crude odds ratio, that measure, that estimate, it has bias in it. So due to confounding. So I don't want to report the unadjusted. I am going to conclude that these odds ratios, these are going to be the more valid. They're going to be the best estimate that I can provide for the relationship between race, ethnicity, and the denial of health or life insurance.